Hi, my name is Ariansai, and in this video I am going to demonstrate the partition tolerance test of a CP system. I have used MongoDB as my CP system. So the test case to be covered during the video is creating a replica set, creating a network partition, adding data during partition, and restoring the network partition. This is the architecture that I've employed for this network partition. I've launched a cluster of 5 MongoDB instances. I have launched my MongoDB instance in 2 different private subnets. I don't want them to get exposed to public, so that's why I've deployed them in private subnets. And let's see the structure. So these are the 5 instances that are participating from the cluster. I have used the security group SSH22 to so I have followed these steps to create a cluster, and here I have given my IP to initiate the cluster config, and so I've initiated the process and my cluster has been created. I've already SSH into my clusters. I've entered into my database and to Mongo shell, and I'll check the status of my cluster. So this is health 1, this is health 1. So my cluster is healthy. So this is the name of my cluster set. This is my personal project, and this indicates the members who are participating to form the cluster. It shows the IP of the instance and health, whether it's working or not, and state string. It shows whether it's a primary or secondary, because MongoDB follows a master slave replication. Let us check our primary instance. So 10.2.53 is our primary instance. So I'll go into my instance, I'll SSH it, I'll go into my Mongo shell. So this gives me primary. So I'll enter some data, and I'll create a database called test, and I'll create a collection called towns and enter the data, and this should be reflected through all the partition, to all the instances. Let us see. So we can see all our data is returned. Let us query the data. So the data is entered into a primary instance. Let us query the same data in one of our secondary instances. So you can see one of the secondary instances got the data. Let's check other instances as well. The data is reflected here also. The data is reflected in our third instance also. Let us check our final instance. So our data has been replicated on all our instances. So our cluster is working properly. That the data has been replicated across all the instances of the cluster. So now we'll create a network partition. So I'm going to create a network partition for primary database, which is this one. And when you create a partition of your primary, if your primary goes down in MongoDB, a new primary has been elected by using election algorithm. Let us check how this goes. So I'll create a partitioning using iptables command. So I have created the partition. Let us go into the Mongo shell. See, initially it was primary, but now it has become secondary. Let us check the status of the cluster. So here the other nodes health becomes 0. So this shows that the other node there, it's not able to talk to other nodes. Let us check which is our new primary. So I'll go to one of my instances, and rs.status. So So the cluster is not able to reach the our previous primary instances. Let's check a new primary. So 10.0.172 is a new primary. Let us go into that instance. Let us enter. So this becomes a new primary. So a new primary has been elected during the partition. So test case 2 passes. Let us check like how it will so since a data has been partitioned, if you try to add the data during the partition, it will not reflected in the nodes which have been partitioned. So if we add a new data, it will not reflect in the partition node. So let us do that. So I have other data to be entered. So previously I have inserted 5 objects and now inserted 3. It should be 8. Let us check. So I have 8 items now, and let us check whether it has been reflected in the instances which are present in the which are not in the network. So our data is reflected. So this is a fault tolerant system. So even during the partition, our cluster is working well fine. So the data is replicated. So our data is replicated in all of the instances which are not present in the partition. Let us check the partition node once again whether it receives the data or not. It should not receive a data because it's under partition. So since it's a network error while running, so we should not be able to query the data. So our third test case passes. Now we'll restore the network partition. So when we restore the network partition in a CP system, the data changes which have been made in the database should be reflected in the partition node. So this is known as eventual consistency. Let us drop all the network partitions which we have created. It makes it my Mongo shell. So I have removed all my network partitions. Let us go into our Mongo shell. Let us check the status of our cluster. So our cluster is back again healthy. So our current node is able to talk to the cluster. Let us check the data. So the data has been replicated during the network partition recovery, so it becomes consistent. So we have seen how a CP system behaves under the network partition. Hi, in this demo we'll do the partition tolerance test of our AP system. I've chosen Riak as our AP system. First, let us see the deployment diagram. So this is my Riak cluster. I have launched in a private subnet, and since they are launched in a private subnet, I have created a jump box which so that I can access my private instances. I launched in them in my private subnet because I do not want them to expose them publicly. Let us see the AWS. So these are my Riak clusters. This is the security group of my Riak cluster. So first we'll create the replica set from the steps that are available on my GitHub. So I'll first create let us check as I've already SSH into my cluster. Let us check the status of a cluster. So my cluster is up, all my instances are running. Let us first create a bucket and we'll add the data. So I've created a bucket called capital and I have activated it. Let us check whether all our instances of our cluster are ready or not. So they have written me OK, which means they are running. So let us add some data. Here I'm adding a new data. So I have added the data, and let us check whether our data has been replicated or not. As you can see, our data has been replicated in all of our nodes. So our test case 1 passes. Let us partition the node. So I'll be partitioning the node between 1, 2, 3 and 4 and 5 with sudo iptables command. So let us partition the nodes. This is my node 4. So this is my node 5. So I've created a partition between 1, 2, 3, 4 and 5. Let us check the status of our cluster. So even after our partition, our cluster is still available. So our test case, so this suggests that Riak DB is an AP system which is available during the partition. Let us add data during the partition. So I'll add a data with the key Ohio in node 1. I have added data with the key Ohio in node 1, which will be replicated in 1, 2, 3, and I'll add a new data with the same key Ohio on our nodes 4 and 5. So the data has been added. Let us query the data of the key Ohio from all the nodes. This should return two values. So the node 1, 2, 3 returns Chillicothe and node 4 and 5 returns Columbus. So let us recover our partition. So after I recover the partition, the data will be replicated. But since we have used one key, let's see what will happen in this situation. We'll recover the partition. We'll recover the partition. Let us query the data of the key Ohio and see how it. So it's still not reflecting. Let's query it again. So the nodes reflect the key Ohio as a value Columbus. This is because I have written Columbus later. First it was Chillicothe. So in an AP system, whenever you write key, since Riak is a key value pair, in AP systems if you write, the last write wins. Since I wrote Columbus later, it wins. So this is a successful demo of our Riak DB partition tolerance.